Okay, so now we discuss question 12. So it says that determine the values of current through R1 and R2 in the circuit shown in figure 3.4. Given that when S1 is open and then the second one is when S1 is closed. So I will draw what will happen when S1 is open and when S1 is closed. This one is when it is open. So when it is open, basically the current have to pass through here lah. So you basically can ignore this part. Okay. So this is what will happen. Okay. Now, like I told you before, uh, you need to use Kirchhoff's law when you have more than one EMF. Okay, it doesn't have to be more than one loop. In this case, you only have one loop, but you have two EMF, epsilon 1 and epsilon 2. So I add the label here, epsilon 1 and epsilon 2. And the rest is the same. So I can't apply the first rule because there's no junction. You only have one loop, right? So basically you want to apply the second rule, okay, which is summation of epsilon equal to summation of IR. But before we apply this one, you have to determine direction of loop and the direction of current. So like I told you previously, if you wanted to determine the direction of loop, my suggestion is that you follow the one with the largest EMF. So you have two EMF over here, one is 3, another one is 6. So obviously you want to follow the 6 volt. So the 6 volt, you just follow the positive part here, positive terminal, just goes out from here. Okay, so if I do that, then my loop direction will have to be in this direction, something like that. Okay, so arrow is like this, like that, and like that. Okay, after that you have to determine the direction of current. So if it is possible, if there's no restriction, if the direction of current does not it's not given, it's best if you can follow the direction of loop as well. So logically you want to put it like that. And since there's no junction or whatsoever, you only have one values for I. So you don't have I1, I2, I3, basically you just have I for the whole circuit. Okay, so apply the second rule. For the left hand side, you want to add all the EMF. So you have two EMF, EMF2 and EMF1, so you have to consider both. Normally I'm going to start from here, so it will be EMF2. It's a positive because it goes out from the positive terminal. And then it goes in this direction. You follow the loop direction, and then it goes down over there, and then goes out from the negative terminal. So because of that, you have a negative EMF over here, negative epsilon 1. Remember, because it goes out from the negative terminal, following the loop direction. Okay, now you want to determine the right hand side. Okay, right hand side you have 3 resistors. Again, you can start from here if you want. You have R3, which is corresponding to I. R1, again same current, and R2 that has the same current. So normally I will do it like this. Just put everything there first. I R1 and I R2, and then I determine the sign convention, it is positive or negative. In this case, because we are drawing the direction of current to be the same direction with loop everywhere over here, so you can see that it is always positive lah. See, positive because loop direction and current direction are in the same direction. So positive here, here, and here. Now you just have to substitute all the values. So R3 is equals to 4. So 4I, R1 is 3, R2 is 5, and on the left hand side you have 6 minus 3. So left hand side is equals to 3, right hand side equals to 7 plus 5 is equals to 12 I. So I is basically 3 divided by 12, which is 1 over 4. That means it is 0.25. So this one is current, so it will be ampere. Okay, so actually the question wants to find the current passing through the R1 and R2. Okay, but the currents are is the same over here and over here. Okay, the next part, what will happen when the S1 is closed? So when S1 is closed, okay, what will happen is that if you imagine this is the current flows in that direction, and it meets a junction over there. So over here, current has two options. It's whether you can choose the one without any resistance over there, or they can go through over there with a resistance. So obviously, the behavior of current, if you have something there's no resistance, all current will flow over here. Okay, so this one is like a short circuit cases. So basically, the current just pass through over there, so you can ignore this part. Okay, so because of that, you left with two resistors, like in this example, like in my drawing over here. Again, you basically want to apply the second rule. Okay, first you have to determine direction of loop direction and then the current direction. So loop direction, again, you are following the one with the biggest EMF, which is 6. Follow the positive terminal, and then this would be your loop direction. And then for your current direction, again, you try to follow the loop direction if possible, so you're left with something like this. Okay, so again, you only have one current, so it will be I. So for the left hand side, you have 2 EMF. I will start from here again. So you have epsilon 2 and epsilon 1. Okay, then determine the sign convention. Here it goes out from the positive according to the loop direction. So positive over there. And over here, loop direction is to the right, so it goes out from the negative terminal, so that one is negative. Now you're left with 2R, R2 and R3. We have the same current because there's no junction. And then since the direction of loop and current across the resistors are the same, so you can say that these two are positive. So now you have R2, which is 5I, 4I. So this one is still 6 minus 3. So 3 is equals to 9I. So I is equals to 1 over 3, which is 0.33 ampere. Okay.